Hello students. Hello students. So I hope this you remember the points which I have mentioned for the upcoming weekend test. So you have to go through horizontal circular motion, all the points in motion in a plane, and laws of motion. There we come. We have some applications of circular motion, right? What is that? Motion of a vehicle on a circular road, motion of a vehicle on a curved road. That also you have to go through. So level 1, level 2 questions. Try to go through only level 1, level 2 questions. Don't right now. Don't write other questions. Okay. Practice this part. And that is motion with plane, uniform circular motion based questions. Then laws of motion, applications of circular motion. That is motion of a vehicle on circular path. Then when work energy power, vertical circular motion. These concepts. Okay. So try to um, this guys. I hope are you getting my voice? Right. So a few points. Let me recollect back related to applications of circular motion. That is motion of a vehicle on circular path. Motion of a vehicle on circular path. There is a circular turning on roads also. Motion of a vehicle on a curved road. On a curved road. On a curved road. I think some of you have not joined this link. Some other link you guys have joined itself. Inform the others. Okay. Motion of a vehicle on a curved road. So with friction, without friction, also you have to just, of course, the concept of friction also you have to remember and you have to apply here, guys. Okay. The maximum velocity of a vehicle on a curved road, a circular curved road, without friction will be V maximum is equal to, maximum curved road without banking with friction is square root of mu r g. Mu is coefficient of friction of the road, and r is radius of curvature of the curved part of the road, and g is acceleration to gravity at that particular part. This one without banking. With banking, it changes provided. If the road is having a banking but there is no without friction, and banked road without friction, then V maximum is equal to square root of Rg tan theta only. Rg tan theta only. If it is having friction and banking both together, then then you can say V maximum will be equal to square root of Rg into tan theta minus mu by 1 plus mu tan theta. 1 plus mu tan theta. Root for the entire thing. So these relations we want to make use. Page number 206. 206. The question is centripetal force required by 1000 kg car that takes a turn of radius 50 meter at a speed of 36 km per hour is right. If you go through the question, you'll get an idea. What is given? The centripetal force required by this R is equal to 50 meter 50 meter at a speed of 36 km per hour. At a speed of V is equal to 36 kilometer per hour. Multiply this R. M is given, V is given, R is given. Substitute, we'll get it. That's it. So we get 2000 Newton. Right, yes. Next, similarly, let us do one more question. Question number here in this exercise only. Level 1 exercise 1 only. Question number 48. 48. Let me read the question first. Let me read the question. The question is, a stone of mass 0.5 kg is attached to a string of length 2 meter and is whirled in a horizontal circle. If the string can withstand a tension of 9 Newton, means a maximum tension of 9 Newton, the maximum velocity with which the stone can be whirled is blocked to a string. The length will act as the radius. Its center at this point and mass at the other end. Okay, is whirled in a horizontal circle. If the string can withstand a maximum tension of T is equal to 9 Newton, maximum tension of 9 Newton, the maximum velocity with which you can whirl is, the maximum velocity with which the stone can be whirled is. So to understand this, we have to use the centripetal force formula. Centripetal force is nothing but mv square by r. The force developed here, centripetal force developed, is nothing but the tension developed in the string. So this can be equated to tension T. From this we can write V, maximum tension is given by maximum velocity. So corresponding maximum velocity square is equal to T into R by M. So, V maximum is equal to square root of that. So V maximum is equal to square root of T. Tension T is how much? 9 into R is how much? R is nothing but L into 2 by M is how much? 0.5. 0.5. Here 0.5 can be expressed as 1 by 2. 1 by 2, that 2 goes here, it becomes 4. So you can write it as 9 into 4. 9 into 4, or if it comes out of the root, it becomes 3 into 2 is equal to 6 meter per second will be the maximum speed. So option 1, if you see here. So V maximum is equal to 6 meter per second. This much speed if you give, the maximum tension developed can be equal to 9 newtons. And to develop a maximum tension of 9 newtons, you have to give a maximum speed of this much. Yes, guys, there is a network issue it seems. Are you getting this? Try to work out few questions from level 2, level 2 exercise 1 and level 2 exercise 2. These are all the questions we have to go through this.